Hello, SCR321 TA and Professor. This is a screencast showing my assignment 5, the functionality of the program. So start off with, we're gonna do an execution of 5 terminals, each one respectively, to run 3 instances of a node, the leader that does the processing, and the client that's going to provide the input values, and also and as well deliver the output results. So let's start off with. So start the program will be start the leader. I have here in my terminal leader node 1, node 2, node 3. As you can see here, this is a clear CLI, like using just the command line as my interface. The purpose of the program is just to demonstrate concurrent computation using multiple node processes, as well JSON-based message passing, and a basic consensus protocol to detect and correct a faulty node's computation. All right, to start off, I'm going to run leader. Start that off. All right, starts on the port 7000, and the instances will be subsequently after that port value. I'm going to now run node 1. Okay, started node 1 on port 701. Now I'm going to run node 2. Give that time. What else can I explain? I can explain the basic consensus verification. That's for the regards to the single faulty node. But that'll be the second task. For now, just the results. 3. Start that port. Okay, port 702. Tough cookie. Okay, 703. Now run the client. Okay, now we got that running. Right now I'm demonstrating to you a distributed, what I'm representing here is single sum calculation. Let's go back. Okay. So what's going on here with regards to single sum calculation? So the leader would calculate the sum on its own, and I'm going to provide an X millisecond delay to each iteration to simulate a time-consuming calculation. So I'm going to provide an input values of integers, a value, and that's going to be summed up, and there's going to be a delay of 50 milliseconds. So per every instance of value, so like first index plus second index, there's going to be a delay, and then second index add the sum of third index, that's going to be another delay. So this is gonna result in this practical sense of a computation time and final sum. So let me show you the single sum calculation. I just need to enter the sum. Okay, 20. I'm gonna put in. Okay. I'm gonna put in the delay value. says here, enter the artificial delay per number. I'm going to put a 100 milliseconds. This should give me 210 with 3 nodes. That's the single thread sum, distributed sum, and distributed computation time. Oh, we show you the different time comparison for distributed and the single threaded time. As you can see, the distributed computation time is much more faster than the single threaded time. Okay, I can also do faulty node. Show that one. Let me just stop one of these nodes, and I can put a flag on one of them. Simulate a faulty node, form a faulty calculation, but the leader catches that, and there's a protocol that detects the discrepancy and corrects the final result. So let me run with an argument with the flag. Okay, it's gonna be run again. Now you can see here it's gonna be faulty nodes, right? Okay, now we're going back to the client. We're gonna run this again. Start the daemon. Just want to demonstrate this faulty node simulation. So right now, node 2 will intentionally produce an incorrect sum for its portion. I'm right now going to run the client again with new inputs, and the protocol in place in leader will detect the discrepancy and they will correct the result. And the leader will also tell me which node was faulty and how it was handled, and the client, and then the response and the result was that the client will receive the correct total. All right, so let me begin. Let me enter once again the some values. 20, 30, 40, 50, 60, and then enter the artificial delay. Okay, so as you can see here, we still got the results back of the correct sum. As you can see, the distributed computation time was more faster this instance, and also there's a note I provide here that the leader sends back stating which node was faulty that produced an incorrect partial result, and it was corrected by the consensus protocol. Okay, hope that helped. Let me know if you have any questions, but yeah, that was fun.